Hey guys, IT guy Michael here and welcome to another lecture of our course for classification in Python. In this lecture I'm going to call about grid search or hyperparameter optimization, hyperparameter tuning. Now let's jump right back to the Jupyter lab. Now what's the issue? So far we were using the KNN and logistic regression as the black box. So we were just importing the algorithms without any knowledge. In the first like two videos ago I just briefly described what is KNN and I just said that it's computing the class based on the neighbors from the train set, right? So if you look into the scikit-learn documentation, the k-nearest neighbors has all these parameters. So for example, you can set the number of neighbors, you can say the weighting function, you can set the algorithm, right? So then you can set the leaf size, then you can set the p, then you can set the metric params and jobs. So all these things are being parameters for the k-neighbors classifier. And so far we just import it and use it without any setting, right? So only the default parameters has been set. Now, the thing is what if some of the parameters are better for your classification problem? How are we gonna do that? Okay, so for this purpose, something which is called a grid search is being used. So in this case, in this example, I'm just going to test just these three parameters. So I'm going to test how many of the neighbors are optimal. So how many of the k in k nearest neighbor stands for how many neighbors are going to be put to voting of the class. So I'm going to try to guess the number of them and how does this number affects the performance. Then what distance metric should be used. So how are we going to compute the distance in the feature space? Manhattan distance, Minkowski distance, Euclidean distance, and we also going to set up something which is called a leaf size, which can drastically optimize the results. I'm gonna go into the details of it, but you can read it inside the documentation on the internet, so please be free right now. I want to show you this. Many times there are the parameters which even I don't understand, right? In some cases, in some algorithms. But using the grid search allows me to experiment with these parameters and get all the possible combinations of the parameters to know what is the best results. And this is exactly what grid search does. So let's just look at this. So I'm importing the k-near neighbors, splitting, and the metrics things right? And then I'm setting the train test and XY set, right? The same way as before. And as you can see, this is the prediction without anything, right? So I'm just straight predicting the X train, Y train and get the results. Now I'm going to do the grid search. So first, how are we going to specify the grid search? So you need to specify the model. So in this case, it's just the empty k-nearest neighbors classifier. And then you are specifying the parameters which you want to play with. So for the P, which is the P parameter is saying which of the distance metrics are we going to use, right? So as you can see here, in case of 1, it's equivalent to Manhattan distance. In case of 2, it's Euclidean distance, and in other cases, it's just a Minkowski distance being set for us, right? So I'm just gonna play with these 1, 2, 3 options, right? So Manhattan and Euclidean and Minkowski. Then the number of neighbors, I'm going to play with the list of number of neighbors. I'm running from 2 up to let's go 30 and increasing it by 5, right? And then I'm going to put, this is a dictionary, a Python dictionary, put this into a grid search CV. The CV stands for cross-validation. I know I talked a little bit about cross-validation in the previous video. We can talk about it one more time here. So here I'm setting the model, and here I'm setting the paramdic, which is the parameter dictionary which I created over here. Here I'm setting the number of times the cross-validation should repeat for each of the combinations of parameters. So grid search will create for each of the parameter combination a separate run with the algorithm. Then we will always run this for the train set, okay? Then for each of the run, cross-validation will be run 3 times. So what does it mean? In each of the cross-validation run, the train set will be split to a training part and the cross-validation part. Mostly 80 to 20. Depends, right? Then it will be done 3 times. So first, second, and third. For each of these runs, the classifier will be trained on the train set and evaluated on the cross-validation set. 3 times. In each of the cross-validation run, different portions of data are being used in train and cross-validation set. So the classifier, the cross-validation run will have 3 values. Then the average is being computed as the result of the cross-validation run for the given grid search run. Okay? And this is called a k-fold cross-validation approach, right? Because we are running the cross-validation for k-folds. And then the result is being then computed for each of the grid search combinations of parameters, right? And the output will be the best combination of parameters based on the cross-validation, right? So we are not using the test set in the grid search, but we are using it in the we are using train set in the grid search by applying the k-fold cross-validation technique. This could be quite confusing. If you are still confused with the k-fold cross-validation technique, write a comment down below in the discussion, or go to the internet, try to find something. I'll be glad to help you. So then you can see it's just simple as running grid feed, right? This will put here all the possible combinations of models. And then you can say, okay, best model, get the best estimator and show me the params. And these went through 540 combinations of all of these parameters, right? It took me 19 seconds, which is quite fast. That was not a lot of data. K-nearest neighbor classifier is very fast. And the best possible combination was the leaf size of 1, metric of Minkowski. These are the auto default parameters, which I didn't set. The P of 3, right, and weights uniform. So the default parameters were just set for me to default, right? So, and then I'm using here the best model to predict on train and test data, and look at the accuracy and precision. 1, I have 100% precision in case of predicting whether somebody will go or will stay. Yes, of course, I'm not reaching to all of it because the recall is low, but the recall in 0 is all, and I have 96% of precision. The F1 score is 96, 0.96, which is very good F1 score for this kind of problem. And as you can see from the confusion metrics, you can see that there are 0 false positive cases. So whenever I'm saying that somebody will leave the company, he will leave the company, right? How amazing is that? By leveraging the grid search, I can find the optimal combination of parameters for the given KNN, right? So okay guys, so this was the grid search. You can in the next video I will show you how you can apply the grid search, how you can apply all the knowledge which we learned right now to this kind of example, and how you can make a very clear pipeline implementation of the machine learning algorithm in the Jupyter lab. Thank you very much for watching this lecture.